Okay, so guys, shall we start the class then? Right? We
Okay,
start the
sir.
class. Okay. So, who's Metuka? Who's Situka?
I am Mathukar.
Alright, you're Metuka and
I'm Tipukar.
you're Situka. No? Okay. So, I'll be recording this meeting just in case others might want. So, guys, there are 2 days, right? You can join any class. So, this is one class on Tuesday night, and the other day is Sundays in the morning 7 to 9. Harid? So, you can join any of them. I'm just going to pin myself, right? Okay. You can see me now, no? Right, okay. Now, first of all, you all are going to be doing your IGCSE exam in 2027 May June, right? Then,
Yes.
what are your schools? Which
And
school
your international school Kasapugas Kandar.
you are going to?
Your international school Sapugas Kandar.
All right. Okay. Great. Okay. Now, your grade 8 haven't finished yet, right?
No.
It's still like it's at the end of finishing now. If I'm
Yes.
right. Okay. So now, this is not the usual place that I do class. I have a separate room upstairs. I mean, you can't come physically, ne? It's too long for you, no? The distance,
Yes.
you are in Sapagaskanda in the sense, it's far away, ne? From Gorlas
Yes.
Gate. Okay. So, initially, before doing anything, I'll just go over your syllabus, right? So, you are new to this topic, no? You are new to this topic, I'll just go over your syllabus, right? So, you are here, my name is Venuja De Silva, right? My name is Venuja De Silva. And if you have any issue, you can call that number of mine. Okay, Puta? You know the number, right? You can just ask me if you have any question related to physics. Anityavat Puta kamak nahi. You can just ask me, right? Any question. Okay, and I just need to let know about you guys as well. So you are Situga. Situga is raise your hand, Situga. Oh, it's gonna be an issue there. You are Situga, right? That is Metuga. Do you guys have any hobbies or do you do any sports of such? Do you
My hobby is making kites.
making what?
Making kites.
Making kites. Oh, your hobby is
Yes.
actually making kites. Have you made kites? This is the
Yes.
season, right? This is the season, right? Currently, my webcam
Yes.
is a bit wobbly. I actually my webcam fell like 3 times. Fell to the ground from like a height of about 2 meters. I don't know how it fell. It just fell. Right. Anyway, now this is more focused, no? Okay. So Methuka and Situka, I'll just be going through the syllabus first of all. You have to understand in your IGCSE syllabus, in your IGCSE O-level physics syllabus, there are mainly 8 topics, right? There are 8 topics. So those 8 topics, I won't be writing all of those 8 topics down. Maybe I think I should write down. So you guys get an idea, no? Right? I think that's better. So I'll just write down all the topics that will be coming for you. So I'm going to basically initially I'm going to give you a breakdown of the syllabus, okay? The meeting is being recorded, right?
Yes.
Recorded? Yeah. Okay. Because otherwise, in our first day class, which was on
Yes.
Sunday, on that day, what happened was I forgot to turn on the recording, right? So I was doing the meeting on Microsoft Teams as well. Then what happened was I had to record everything again separately. Like the live class recording was unavailable, so I had to record everything separately again. Okay. It was like a huge because I didn't have time to. Not only one class, man, every class, all the classes that I did on Sunday, I had to record it again. I don't know how I forgot. I don't usually forget to record classes, but then that happened. Okay, so I'll just be going through the topics, right? You are going to be doing your exam on 2027 May June, right?
Yes.
May June. You'll be writing IGCSE. This is the breakdown of your syllabus, right, guys? You
Yes.
are 2 papers. You are getting 2 papers. Paper 1 and paper 2. Paper 1 and paper 2. Right? So I think with the
Yes.
this light here, you might not be able to see this. This paper 1,
Yes.
right? Then there are 8 topics in your syllabus. There are 8 topics. How many topics?
8 topics.
8 topics in your syllabus. So these 2 papers will consist of all the 8 topics. So MCQs, essays, everything would be in paper 1. In paper 2 also the same. It is a mix of MCQs and essay type questions. Okay. So what you have to understand is paper 1 covers all the 8 topics and paper 2 also covers all the 8 topics mostly. It's like a jumble. You are getting a bit of everything in paper 1 and a bit of everything in paper 2 as well, right? So I don't know, maybe they should have just gone with an MCQ paper and a paper 2 and essay paper separately, but then that's not how it works. For Cambridge, that's how it works. However, they have a essay paper separate, they have a separate MCQ paper and a separate structured essay paper, right? So however, for Edexcel IGCSE, this is how the paper works. So I told you there are 8 topics, right guys?
Yes.
So those 8 topics, these are those 8 topics. So listen up, I'll just erase this part. Because this is what you'll be studying for the next 2 years. Again, all of 2 years, right? Okay. So the first topic is forces and motion. Forces and motion. Let me forces and motion. I have divided. So your syllabus is actually 8 lessons. Your syllabus is 8 lessons. I have divided each lesson, right? Each lesson divided them into separate subtopics. For the first lesson, I have divided the first lesson into 4 subtopics, right? 4 subtopics is divided. So those 4 subtopics, the first subtopic I am going to be putting as 1.1, second subtopic 1.2, third subtopic 1.3. So here you should understand, today I will be teaching you starting with 1.1. So up to 1.4 this goes. So right? You are watching what where are you watching? Okay, so you're listening? Okay. I was just kidding. Okay. Right. 4 subtopics, so there are 4 subtopics. Right? Okay. So I'm just gonna put, I'm not going to put anything. I think I'll just put 4 subtopics in there. So 1.1 1.2, 1.3, 1.4, right? Then lesson number 2. The second lesson is electricity. Electricity. So under electricity, there are again 4 subtopics. So this is 2.1, 2.2, 2.3, 2.4. Third lesson, the name of the third lesson is waves. So waves, you will be learning about like what are electromagnetic waves, transverse waves, longitudinal waves, sound waves, right? Those basic things regarding to waves, and then you will learn about reflection, refraction, those stuff related to light. Okay. So under waves, however, there are only 3 subtopics. Okay. 3.1, 3.2, 3.3. Then so while I am doing, you are getting bored as well. While I am writing this down, you guys have to calculate at the end of the time when I have written for all the 8 topics. How many subtopics are there in your complete syllabus? Right? So then you will get an idea on what I am doing. You calculate. So the 4th lesson is energy resources and energy transfers. And energy transfers. Okay guys, so there are again 2 subtopics only under energy sources and energy transfers. Again, energy sources and energy transfers we are learning how energy is transferred. Convection, conduction, radiation, we are learning, and then we are learning basics of heat. Thermal physics, we are learning about thermal physics, right? So related to heat, you guys have done science, right? In science, heat you have learned, temperature, those stuff, right? Petty stuff. So that's only two subtopics, only 4.1 to 4.2. Then For lesson number 5, guess number? You can't guess, obviously. I mean, this is the first day that you are learning about this stuff, right? How can you guess? We've got something called solids, liquids, and gases. Right? Solids, liquids, and gases. There are 3 subtopics: 5.1, 5.2, and 5.3. That's what we have. Okay. So under this we'll be learning about density and pressure. We'll learn about changes in state changes. So how state changes happen, those things. Then ganam karna nahi? You're counting now how many subtopics?
Yes.
Okay. Lesson number 6. Now we are nearing the end. Okay. Magnetism and electromagnetism. You may not understand these words. Magnetism and electromagnetism. Okay, magnetism and electromagnetism. So there we've got 6.1, 6.2. Only 2 subtopics only. We'll be learning about magnets, permanent magnets and temporary magnets. You won't understand this stuff yet. But then gradually you'll understand when we are going through our lessons, right? Then lesson number 7, radioactivity and particles. Okay, so there under lesson number 7, we'll be doing 3 subtopics. Okay, 7.1, 7.2, 7.3. Under radioactivity and particle, have you heard of something called particle physics? We are going to learn about the atoms, atomic particles. That's what we are going to learn. That is called particle physics, right? So, I mean, it might be like very something out of another planet to you guys, but then it's very easy, right? Even though you feel like it is very hard. Then lesson number 8. What we have got is, for lesson number 8, we have got a topic called astrophysics. This is actually a very interesting lesson. Na? Astrophysics, it is a very interesting lesson actually. There are 3 subtopics under it again, but we'll be learning about space under this topic. Okay, 8.1, 8.2 and 8.3. Okay. Now, you tell me, how many subtopics do we have under this?
8.
We have
8.
8 subtopics, no? What? Those are the number of topics. I am asking how many subtopics?
Subtopics 28.
28, really? Shall we check? 4, we've got 8, 8 plus 3, 11, 11 plus 2, 13, 13 plus 3, 16, 16 plus 2, 18, 18 plus 3, 21, 21 plus 3, 24. No, why did you say 28? How did you get 28? How did you get Now do you understand that you can't even add එකතු කරන්නත් බෑ කියලා දැන් තේරෙනව නේද? Who calculated? කවුද calculate කරේ? මෙතකොද සිතකොද calculate කරේ? බලන්න ළමයි. See? Okay. I'll just take a photo of this. It's easier for me. Right, this is actually nice, sir. This is so clear, no? Okay. So next, these are the topics that I'll be covering. Then may have a screenshot tag right? Just take a screenshot if possible. If you can, take a screenshot of this part, and then it will be beneficial for you guys. Anyway, I'm putting this photo to the group, so you'll anyway be able to see it. This is the basic 8 lesson. This is how your syllabus is divided. Okay, right. We'll erase this and we'll move on to the actual lesson. Then actually we are starting the lesson. Okay, so I'm going to erase it. Today I went out and bought this new board. This board is new
Sir,
actually.
we have the physics book.
I don't know. Why? You have the physics book, so? Huh? So? Venuja, so what? No, you see, the issue is in your physics book, in the student book that they give you, everything is very complex for you to understand. And it is very lengthy. The note is very long. Right? It's very lengthy. So what I give is, I give a really short note. You understand? I give a really short note. Is it a bit blurry? Is the camera a bit blurry? I'll post the record. Right. Okay. So now, next what we have got is, we are going to learn about the first subtopic that we just talked about. So write down the name of the first lesson. If you have a book, write down the name of the first lesson. Both of you are writing in two different separate books.
Okay.
Okay. Right. So basically, you should understand, you should need a 160-page book. CR Pada. As this is the first, it's okay. First day Nisa, it's okay. But then take that note in your, if you are writing in any other book, convert it to a 160-page or 200-page CR book. It's safer because then the complete note will be in a single book. It would be much easier for you guys. Alright. Now, write down topic of the first lesson. Then 2027 IGCSE Edexcel, you just put something like that for the beginning. First day, no man. First day in product ne hondara patan ganna. And make sure you keep your note tidy, neat and tidy. Kurutugala the end what this is physics note. This is not like your maths book. What balan nitin netiya. Maths book it's okay. Maths book you can do whatever you want because in maths you just need to do many questions. So cut it, paste it, it doesn't matter. Physics book you have to keep it nice and tidy. Okay, right? Then you write down here. Lesson number 1, forces and motion. Forces and motion. Forces and motion. Right. So under this, that is the main topic. Main lesson 1. Out of those, I told you 8. There are 8 lessons. So out of those 8 lessons, this is the first lesson. Right. There are 4 subtopics under this. Right. Then only we are going to move on into the first subtopic. Force and motion dala. You put 1.1, and then write down movement and position. Movement and position. Okay. Right. Movement and position. Okay. Done? You got it?
Yes.
Good. Okay. Now, movement and position. So, what is movement? What is movement? Movement first of all, tell me what is movement.
Movement is when we move, ability to do work.
Movement means ability to do work. Yeah, that is kind of correct. Not exactly correct, not the exact definition. But however, movement means it could be maybe going from one place to another place, right? Simple as that.
Yeah.
Just motion. Movement means a certain kind of motion. Not exactly going from one place to another place. I am raising my hand from here to here. From here to here, I am raising my hand. I am raising, right? That is movement. I am writing in the whiteboard. That is also movement. You don't need to just go from one position to other. Understood? So that you have to understand first of all. Okay. Now, guys, next what we have got? We have got the first part. So initially under movement and position, we are learning about something called distance time graphs. So this is not new to you, right? You did learn about distance time graphs, neither. Under science, grade 8 science, did you? Did you? I'm not sure. I have never teach grade 8 science. I only do O levels and A level physics. IGCSE, Cambridge Edexcel. In grade 8 science book, did they teach you about some graphing part, distance time graphs? No, neither.
Yes.
They did know. Lookman, don't you have a term test for grade 8? Or then term test grade 8 then for the third term.
Yes.
So aren't you great? Really? Okay. Anyway. We'll keep that. That's in the past. No? So now it's a new beginning. Grade 8 you start from now. Whatever results you got in grade 8 doesn't matter now. It can change. Okay? Right. So this distance time graphs, this is how a distance time graph look like. Basically, we are in a distance time graph, what we are doing is, we are putting distance or displacement to the y-axis. You know this is the y-axis, right? Y-axis distance or displacement, right? You know why I am placing both of these in the same one. This is because in graphing, distance and displacement you will get to know that later on. Make a lesson you will get to know that. However, you have to understand during graphing, distance, displacement, we are taking both of them as something equal to each other. We are taking both of them similarly. Distance and displacement are two different quantities, but we are taking both of them similarly. For this graphing part. Next what we have got is, we've got time here. Time here. So distance and displacement actually it is measured in meters. Are looking down? Who's looking down? Look at the board.
I was writing.
Don't write. Oh, what are you writing? Hello? What are you writing? You are writing what's in the book? Ayo, no. Buddha.
Yes.
Listen carefully when I am teaching. Then I will give you time to write. That is 5 and a half. Okay? Right? So we have enough time. Don't worry. So this is displacement. This is time. So teaching on that you just try to you understand everything, right? Then when you are writing, what it would be much easy for you. You guys are doing any sports at school? Are you doing any sports?
Cricket?
Not doing any sports?
No, we don't.
I know. So you guys have plenty of time to study as well. Okay, so out of the people I know, out of the students that I usually teach, most of them do sports. That's right. Anyway, it doesn't matter. Somehow in distance time graph, this is what you need to know. Make a basic structure. Make it. Inside of this graph, we can draw separate things. We can represent speed or velocity that we can do. On the other lesson, concentrate right? Okay? Now, you understand, in this distance time graph, can you guys remember how you represented velocity in this distance time graph? Velocity is the speed. Can you remember how you represented that?
And distance divide. Do you have to find the speed?
Yeah, no, not find the speed. What you have to do is make graph. Can you tell me how to draw speed? How to represent speed in this graph? This is a distance time graph. How can we represent speed in this graph? Listen, you just have to look at it, remember it, study. Okay? A straight line through the origin. We call this a straight line through the origin. Now you remember, no?
Yes.
Okay, so this is actually constant velocity. constant velocity. Uda, this is how constant velocity is represented in a distance time graph. Okay, constant velocity, right? Next, what we have? Next we have, what do we have next? Next we have, so make a distance time graph. You have to understand, you have to know how to take these measurements. Have you heard of something called gradient before?
Yes.
What is gradient?
Gradient is distance divided by time.
No, yeah, that is correct. Distance divided by time you get for here, ne? Constant velocity, speed. Speed කියන එක දෙකම ලියාගෙන මොකද දන්නවද? If this is the displacement time graph, it is constant velocity. If this is a distance time graph, it is constant speed. ඒක දන්නවනේ?
Yes.
Okay, right. So just don't write down it. Oh, are you writing?
No.
Alright, මුකුත් ලියන්න එපා. හොඳයි. I'll give you time. So I need your full quote attention now. So this shows constant velocity, right? You told me gradient is displacement divided by time, or distance divided by time, right? That is the. So what do we measure by the gradient? අපිට මොකක්ද දෙන්නේ gradient එක distance divided by time කිව්ව මොකක්ද in a quantity එක? What is the quantity that we are getting? Yeah. Sorry?
And velocity.
Speed and velocity, right? Speed, you can say one word. That is, so basically, just use one word. In distance, only in this graphing, distance and displacement, we take it as similar. Because in your paper, sometimes they give you a displacement time graph and then just ask you to find distance. Speed time graph at the logging on a distance. Like, you understand? Displacement time. Then we are taking these two quantities, even though they are different. We know that they are different, but we are using it like that. Okay?
Yeah.
Right, okay.
Okay.
So out of the gradient, we are finding the speed or velocity, right? We are finding the speed. So Methogan Situga, we have to understand we have to understand gradient the value of the speed, right? In a distance time graph. What's the speed object? That is what we are finding through the gradient, right?
Yes.
In value, no? So gradient is equal to delta y over delta x. Change in y over change in x.
Yes.
You don't know what is delta, right? I'll just tell for other people who watch this recording. Delta means change in. What we are doing basically is we are taking 2 points of this graph, right? And then we are drawing a triangle like this. Triangle this is the y-axis, no? Distance. We are calculating this distance. This is delta y. Then in the x-axis, in this triangle, we are calculating this delta x. Right? Now you remember, right?
Yes.
Delta x, so delta x over delta y over delta x is the gradient actually. So in a distant time graph, gradient is equal to speed or velocity. When the gradient is increasing, when the gradient is high, the speed is also high. When the gradient is low, I'll draw it in the blue color pen. When the gradient is low, speed is also low.
No.
Make divide karla in a ratio to the ratio that is coming when we divide delta y by delta x. Now understood?
Yeah.
You should know something. If you are given a graph like this, look, this is also a distance time graph. So instead of writing distance as a whole, I am just going to write d, okay? To d can distance. Then for time, I am using t. So you should know time is measured in seconds, distance measured in meters, always. So if you are given a question, a distance in kilometers, it must say time in seconds. You can get the answer in kilometers per second for the speed. However, it is better if you can convert the kilometers to meters and then get the answer, right? Okay. Right. Now here imagine what is this represented by? What does this line represent in this distance time graph? මේ line එකෙන් මොකක්ද කියන්නේ?
velocity.
Yeah, constant velocity. Just use the term constant. Then what does this line represent? මේ line එක represent කරන්නේ මොකද්ද? That is also
Constant velocity.
yeah. Both of them represent constant velocity, right? Straight lines.
Yeah.
They are straight lines through the origin. Distance time graph එකක straight line means through the origin means straight line through the origin means always constant velocity, right? So I am going to name this graph 1 and this graph 2. Tell me which one has the higher velocity, which one has the low velocity.
As number 1 has a higher velocity.
Correct. Do you understand?
Yes.
Number 1 has a higher velocity. Why? Reason?
Because it's going faster.
Sorry, because?
It's going faster.
Yeah, no. That is correct. Obviously, man, higher speed means it's going faster. I am asking, how did you tell one has a higher velocity? Why not 2? 2 can have there.
Because the number 1 has a steeper angle.
Correct. The slope, we make it again a slope vector. So gradient, in other terms, we call it the slope, the gradient. Okay. So the gradient in number 1 or the slope in number 1 is very steeper. And the slope in number 2, it is shallower. Understood? So you should write down steeper slope, greater speed. Is it shallower slope, shallower. We don't call shallow. We call shallower or less steep. Shallower slope, slower speed. Okay, guys. Right. So under movement and position, that is movement and position. You put the subtopic. So movement and position is the first subtopic. No. Eka yata topic එකක් විදියට දාන්න displacement. Sorry, distance time graphs කියලා දාන්න. Put distance time graphs. Okay. Distance time graphs කියලා දාලා you just draw everything I have written in the board. මේ board එකේ තියෙන ඔක්කොම ටික ලියා ගන්න. So put change in කියන එක you දාගන්න. Change in කියන එක. So this is actually a Greek letter. හරිද? මේ තියෙන Greek symbol. It is called delta. We call it delta. I mean delta කියලා තමයි කියන්නේ. Delta කියලා කියන්නේ. Okay? Delta. Got it? So everything copy down and call out to me. Mata, sir, we are done killa. You call out, guys. I'm going to pause the recording, and when we are starting again on the next part, you just remind me to switch on the recording. Okay, we are back again. In this distance time graph, if something like this happens, so this one. Now tell me what is this, guys? Tell me what is this power number again?
It is
Sorry?
distance time graph.
Yeah, this is a distance time graph. What have I drawn? What does this line represent?
It is constant velocity.
Constant velocity, correct. So that is constant velocity. What is increasing velocity? Increasing velocity කියන්නේ what is increasing velocity?
It's going higher. It's
Yeah.
more steeper. Like
No. That is for higher velocity, higher constant velocity. For example, in that other graph that we drew, steeper shallow කියලා in that graph, මෙහෙම තියෙන එක constant velocity is 2 ms minus 1. මෙහෙම තියෙන එකේ it could be 10 ms minus 1. Right? ඔන්න ඕම වෙන්න පුළුවන්. I am asking about increasing velocity. Increasing velocity means an acceleration. Can you understand that?
yes.
Constant velocity mehmana, increasing velocity, how do we represent? So basically I am asking in the simplest way, I am asking you, how do we represent an increasing velocity, or how do we represent an acceleration in a distance time graph? Acceleration එක කොහොමද represent කරන්නේ in distance time graph කියලා මම අහන්නේ. How do we do that, guys?
Just divided by time?
Yeah, I mean, I'm asking how do you represent? That's the equation. I'm not asking the equation. So this is constant velocity. This is constant velocity. It is a straight line through the origin. This is how you represent increasing acceleration. Sorry, this is how you represent acceleration. The mega you can see a pattern now. This is constant velocity. Constant okay. I'm just writing the constant like this here. What constant? This means constant. Constant velocity. What is this? This is increasing velocity. Or we call it acceleration. Can you understand now?
Yes.
Then how do we represent decreasing velocity? Decreasing velocity we represent like this. Whatever we do here, we are going to the other side, like this. This first one will come correctly for me. Alright, see, it's like a leaf. If we connect it here, it's like a leaf, but we are not connecting. This is just for your reference. This is called decreasing velocity. Call this the decreasing velocity. It is a deceleration actually. Deceleration. Do you understand?
Yeah.
So don't worry. The equation for acceleration, you might be wondering what it is. Or someone who's watching the recording, they might not know what is even acceleration yet. Everything you will be learning next step. You will be learning. Okay, so don't worry. Right. So continue the note. You guys draw this.
Okay, sir.
Writing, just draw this. So I have given a question here. This is in this question. The distance is measured in kilometers. Time is in minutes. You are asked to find the speed in meters per second. So find the speed in meters per second. Right, this is the question. So you copy it down. Those who are watching the recording, pause the video. Straight away don't jump to our discussion. Pause the video, take down the note and then unpause it. We'll be moving on to our discussion part next. I'm not taking the answer, right? So we'll discuss how to get the answer here. So those who are watching the recording, I hope you guys have tried out this question before answering. So find the speed in meters per second. You ask find the speed in meters per second. I was right, okay. Now the distance 8 kilometers, right? This is the distance. Distance is 8 kilometers. Convert this to meters. 8,000 meters. Time is 6 minutes, right? I hope everybody knows this. Okay. One incident happened to me. Anyway, no need to talk about that. One student didn't know how many seconds per a minute. So I'm just going to state it. I hope you guys know it. 1 minute.
Yes, I know it, sir.
See, they know it. 1 minute means 60 seconds. Okay. 1 hour means 60 minutes. Right, guys?
Yes.
Okay. Got it? Right. Great. Now, try to understand. So that is it. That's what you got to do. Then how can we convert this 6 minutes into 6 seconds? So 1 minute is 60 seconds. Then how much is 6 minutes? 6 times 60, right? So what do you get? 360 seconds. Am I correct? It is 360 seconds, right?
Yes.
Putala, this is not 3605, okay? 360 seconds.
Okay.
So then, how do we find the speed? Speed equals distance over time. We already know this. How do we get it? So 8,000 divided by 8,000 meters divided by 360 seconds. What do you get? Is to this cancelled out. You have the other thing is, guys, you have to use a calculator. Did you know that? For now, you are bedalan ganne. You are dividing and taking. You are using the calculator. Okay. Right, great. Okay. Right. So 800 divided by 36, you are getting 22.22 something, right? So this M stays there, and this S goes up. It becomes MS minus 1. Right? So this is the answer. This is how you get the answer. I hope you guys understood this. So if you want, you can pause it and copy it down. Right? Okay. Now we have successfully completed distance time graphs. So next we are moving on. We have velocity time graphs in the syllabus as well. But before moving on to velocity time graphs, I want to solidify your memory. Refresh your memory on speed and acceleration. So that's what we are doing now. You think now distance time graphs done, complete. Write down speed. So you have to now understand we are still under 1.1 now. So let me listen. Write down speed. Speed kila daga. Speed. Okay guys. Down speed kila daga. Write down speed. Okay. Right. Under speed, you already know the equation to calculate the speed is what? Distance divided by time. How do we find average speed? Speed is distance divided by time. Average speed and
time divided by distance.
What? If speed is distance divided by time, average speed can time divided by distance. No, it's not that. Listen up. The average speed can. Now imagine this is city A and this is city B. City A remember this is city B and there is a city C here. City A, city B, city C. Right. So next we have got there's a car. Right. What's your favorite car? Bugatti. I can't draw Bugatti. Can you say, okay, everyone, I am always asking students, if you watch my previous class live recording and shit. Otherwise, I am always asking the students what their favorite car is. They are saying Bugatti, Pagani, BMW, everything they are saying. You know the only car that I can draw. At the end of the day, no matter what my students say, I am drawing that car. For 2026 batch, that's what I did. 2025 batch එකකට ඒක තමයි කරේ. හරිද? එකම හැමෝගෙම මැහුවා මොකද්ද පුතා කැමති කාර් එක? At the end of the day, this is the car I know. මේක විතරයි දන්නේ අදින්නද? This is what I know how to do. මෙන්න මෙච්චරයි. It's something like this. මේක තමයි මගේ කාර් එක. This is not a car. This is like a මොකක්ද මේ minivan එක මොකක්ද I don't know. හරිද? This is okay නේ. හරි. Okay, don't laugh. I need this. I'm a good artist. I'm actually next to Picasso passe then. Ilagara enninne Picasso thamai, right? Okay. I'm still developing. I'm at the development stage. Okay, right. So this is the road. Okay, from city A to city B, this is the road. Right. And from city B to city C, this is the road. Right. Then, guys. Then what we have is I drew a window as well. These are headlights and මෙතන තියෙනවා tail lights. So නැත්තම් බෑ tail lights නැතුව යන්න දෙන්නේ in the road. They are like they are finding you if you go දඩයක් ගන්නවා. Okay, now from point A to point B, හරිද? හොඳට බලන්න. From point A to point B, this car is moving at a speed of 30 meters per second. From point B to point C, this car is moving at a speed of 50 meters per second. 50 meters per second. Right? A to B, from city A to B, मैं constant velocity constant speed 30 ms minus 1 දිගට යන්නේ. මෙතන ඉඳන් B to C 50 ms minus 1 තමයි දිගටම යන්නේ. හරිද? That doesn't change. දිගටම යන්නේ ඒක තමයි. What you have to understand is, if you are asked to find the average speed, හරිද? දැන් ඔයාගේ හුත් average speed හොයන්න කියලා ඔයාට කරන්න තියෙන්නේ 30 plus, sorry, they are asking you find the average speed taken by the car to travel from A to C. A to B ගිහිල්ලා තියෙන්නේ 30, B to C ගිහිල්ලා තියෙන්නේ 50. A to C යද්දි මෙයා maintain කරපු average speed එක හොයන්න කියනවා. ඒතර average speed ගද්දි අපි කරන්නේ A to C ගද්දි මොකද කරන්නේ? So A to B, B to C, A to C directly ගද්දි අපි කරන්නේ 30 plus 50 divided by 2. We get 40 meters per second. Do you understand? That is what we do. Clear now?
Yes.
Okay, right, great. Now, that is 30 meters per second, Buddha. Next what we have got is this thing. Now imagine these velocities are not given. Velocities dila nahi. What dila dina? The length between city A and B is it should be a realistic value as well, 10 kilometers. That means I'll just write 1000 meters, 1 kilometer, 1000 meters. Okay? That is easier for you. 1000 meters. And the distance between city B and city C is 2000 meters scale. 2000 meters. Now, then we should be dividing. We'll put this as 900 meters. You'll understand why. It will be easy for you to understand 900 meters. And we'll take this as, we'll keep this as 50 meters, 2000 meters. So 2000 meters, 900 meters. You scroll down. And let's say for this car to travel from city A to city B, it took 30 seconds. It has taken 30 seconds. And for this car to travel from city B to city C, how much time? We'll put it as 40 seconds. Different velocities, 40 seconds with kilo. Average velocity, average speed is equal to total distance divided by the total time taken. එතකොට question එකක් දෙනවා මෙහෙම වෙනස් දුර වලට මෙහෙම ගිහිල්ලා තියෙන්නේ. What is the average speed? කියලා අහනවා. Average speed you are finding how? Take the total distance 2900 meters, right? Divided by total time, divided by 70 seconds. What are we getting? Divide kala giyana ban 290 by 7. We are getting 41 something, right? 41 something. Api eka gamu approximation එකක් විදිහට 40 තියෙනවා. So that is the value that you got here as well, right? මෙතනත් ගත්ත හම්බුනේ ඒක නේද? අපි approximate එකක්. So පුතා, the other thing is this symbol, this means not exactly equal. It's like a near value, not exactly equal. මෙහෙම බලලා you know it, right? Have you heard about it before? මේ symbol එක, this symbol.
Yeah.
like roughly equal. So roughly 40 ms minus 10, right? 290 divided by 7. Nathan, tell me what you are getting. 41 point something. So we'll take it as 40. Yeah, 41.42 no? Because what I wanted to do was get these two values equal. That's why. Alright? So now, speed kya dala, you copy this, try to understand. Average speed kya dega, you just square. In the exam, if they ask you average speed, you should use this equation now. Okay. Total distance traveled divided by the total time. Do you have any questions?
No, sir.
You understood? Completely understood? 100% you understood?
Yes.
Right, great. In Unison also you said it, right? So this is good. Copy this down to your writing book. So next part. What is it? So what is the next part? We have got the acceleration, right? We have got to learn about acceleration, right? Okay. Now, I told this to you while drawing the distance time graph. What is acceleration, guys? What is acceleration? Try to remember.
It is going up.
Yeah, I called a name to it. මොකද්ද මම ඒකට acceleration නැතුව වෙන නමක් කිව්වා. What velocity? What velocity did I tell? What velocity?
Increasing velocity.
What?
Increasing velocity.
Increasing velocity.
Increasing.
Right? Increasing velocity. Right? So increasing velocity means this is what you have to understand under acceleration. Right? So you know acceleration. You know what is acceleration, right? You understand kind of like you understand it is increasing velocity, but you don't understand it. No, अभी make a understand करें. We'll understand acceleration like.
You're lagging.
Am I? Hold on 1 second. How about now?
Now okay, sir. Now okay.
Okay.
A bit lagging.
Still okay. Shape no. Manageable नहीं है? Shape नहीं? Okay. Now, guys, next what we have got is अपने इलाके में तीनों पता ना. Next we have about acceleration. Okay. So on acceleration, try to understand acceleration like this. Now again I am drawing that car, previous car of ours. Come a car there are these are the tires. With front headlights, and then there are tail lights here. Like this. And these are the windows. And then car के windows. Next, what we have is now someone is saying, let's say I am saying, this car is moving at an acceleration of 10 meters per square second. I am saying this car is moving at an acceleration of 10 meters per square second. Then now what we have is, you understand, you should understand, if someone is to say the car is moving at an acceleration of 10 meters per square second, the first thing that should come to your mind is the velocity of this car is increasing by 10 meters per second every second. Then make a square second within acceleration is 10 meters per square second. So if someone was to say a car is accelerating at an acceleration of 10 meters per square second, you have to understand the car's velocity is being increased by 10 meters per second every second. I'll give this to you separately. But first of all, we should understand the equation to find acceleration, right? Then we should find out what is the final acceleration. So this is the equation. Acceleration equals change in velocity. I'll explain what is change in velocity in a bit. I'll first write it down. Change in velocity divided by the time. If I write this in symbols, Puta, this is how it's going to look like. A equals delta V over T. Now what is delta? We did this previously. Delta V and what is delta?
Yes.
What is delta?
Delta is
What is delta? Can you remember what delta is? I asked you to write down, right?
yes.
What is delta?
Symbol,
Sorry?
Greek symbol.
No, not the V symbol. Delta means change in. Delta can change in. I gave you, right? Change
Yes.
in. V means velocity. See, change in velocity. The thing.
Change in velocity.
Got it, sir? Are you?
Yes.
Change in velocity divided by the time. You should know acceleration or velocity. What is this delta V? Delta V delta V means, or the change in velocity means final velocity minus initial velocity. What examples then final velocity minus initial velocity right?
Final
Yeah, final velocity
is
minus initial velocity. Okay?
yes.
Right. Next, what we have got is T. What does T mean? T means time. T means time, huh?
Yes.
Okay. Then what is A? A means acceleration. Now, abhi mein aage daam hote units. Delta V, or this change in velocity, is measured by meters per second. ms minus 1. Time is measured in seconds. Acceleration is measured in ms minus 2. එතකොට ඇත්තටම වෙලා තියෙන්නේ අපි මෙතන දෙන්නේ ms minus 2 නේ. This is ms minus 1, and when ms minus 1 gets divided by s, we get ms minus 2. මේ පල්ලෙහා තියෙන s උඩට ගිහින් minus 1 minus 2 වෙනවා. Okay?
Yes.
Right? Okay, got it? Right. Now, Buddha, next I'll explain to you what is this final velocity minus initial velocity. There's again another car. Again another car here. That car is moving. Metandi at a velocity of 10 meters per second. Then this is the road. And then when the car is here, right? We are still using the same car. When the car is here, what happens? When the car is here, this car is moving at a velocity of 30 meters per second. So actually, this is final velocity. 30 meters per second is final velocity. 10 meters per second is initial velocity. Car ka patang gatte 10 waliin, end une 30 waliin. So what is final velocity minus initial velocity? Metendi. In this position, what is it? 30 minus 10, right?
Yes.
What do you get? 20. 20 meters per second. That is the change in velocity in this scenario. මෙතෙන්දි change delta v කියන්නේ 20 meters per second. Let's say this happened in a time of මේක වෙන්න 2 seconds ගියා කියලා. The time taken is 2 seconds. So then what is the acceleration? 20 divided by 2, 10 ms minus 2. Understood?
Yes.
1. Then we came back to square 1, right? Now this car is actually moving at an acceleration of 10 meters per second. So these parts are separate.
Yes.
I'll just separate out these parts. Sorry. This part is separate. This is 1. This is what you should write down initially. Then this part is 2. Bottom part. Bottom part. This is 2. And after we got this 10 here only, we are moving on to this top part. Part. Okay, right. I'll just keep it here. Okay, right. Now this car is moving at an acceleration of 10 meters per second. I told you, what does this mean? What does this mean? I'm going to write it down. The velocity of the car is being increased. The velocity of the car is being increased by 10 meters per second every second. Got it?
Yes.
Let's say the starting velocity of the car is 0. After 1 second, what is going to be the velocity? After 1 second, what is going to be the velocity? 10 ms minus 1. Then acceleration is constant. Acceleration is 10 this car is moving. Okay. Then after 2 seconds, what is the acceleration? 20 meters per second. It has to be increased by 20. Velocity of the car is being increased by 10 meters per second every second. After 3 seconds, 30 meters per
Second.
30 meters per second. After 4 seconds, another increase.
40 meters per second.
What?
40 meters per
40
second.
meters per second. So if I ask, by how much has the velocity increased during the second second? During the second, how much has the velocity increased? Second by 10. The third second it has increased by 10. Fourth second 10. So always be increased by 10. That is if the acceleration is constant, obviously. That is how it happens. Initially, this is how you should write down. When writing, this is what you should write initially. Number 1. And then finally only you have write down this part. This is number 3, final part. Write it down to this order, guys. Okay. This order Now, basically that is it, so, right? So that is on acceleration. And acceleration, there's one more thing we have to do about deceleration, right? We have learned about deceleration, but that would be done in our next class, okay? So, however, anyway, whatever you have done so far in this topic, we have done up to acceleration. So next day we'll just a little small part to explain deceleration, and then we can move on to the velocity time graphs and continue the lesson, right? Okay. So anyway, this is what we do, right? This is how it happens. This is how it goes. You have to understand the note that I have given you, right? You can understand it very well once you read it, right? So what I have done so far, what I have done now is I have fed the information to you. All of these are information. I have fed that information to you. All you have to do is you have to process it in the next phase, okay? You have to process it.
Okay.
You have to process the information. How can you process it? After our class ends, after this recording ends, for those who are watching the recording, you have to look at the note again. So look at your note again and then try reviewing. Try to revise at least 2 or 3 times a week with your time schedule. Try to revise the notes that you took today. Right? So that would be it for the recording session. I'll meet you guys on the next day.